This is a quick demonstration of remote cluster job submission through the graphical user interface of the Batch plugin in EEGLAB. Now the Batch plugin is designed to build scripts from the EEGLAB history and then format them so that they can be run on several files by swapping in file names. So an example of a script like this is here, where we have several preprog scripts. And this one we can just edit in any text editor. The key to these scripts is that there are these keystring packs where we have something called the batch DFN for the batch data file name. And as you select multiple files from a browser, it will iterate through this script for every file and swap in the file name here. And we can see down at the bottom, whenever it writes an output file, there's a couple extra pieces of information in this pack where it's actually using the input file name, looking for the underscores, and then removing the end of the file from the first from last underscore and then replacing it with this, and thus changing the name. There are also other pieces of information, these replace strings, that allow you to change properties of the script based on configuration files. Now, in order to run something efficiently on a big cluster, a lot of these jobs get separated into resource demands. And what I'm going to show you is how to run a multiple script, multiple file job submission to a cluster. So what I'm going to do is I'm going to go to Batch. I'm going to run a history template batch. And this brings up the main interface for the Batch plugin. What I'm going to do is I'm going to run a sequence of history files, so these scripts, and these are just called preproc A, B, C, D, and E. And basically what these are doing, without getting into any detail, is A is windowing the data and doing a bunch of filters, and then classifying periods of time and channels that are likely artifacts based on the correlation coefficients between channels. In B, a quick ICA is done to get an idea of the stationarity at certain time points. Now, what's important to note is that proc A, because it dices up the data and does some interpolation, has a lot more memory demands than B, even though B is far more time consuming. Now, C re-windows the data and rewards more RAM, and then D actually performs Amica as an MPI. So the demands are completely different at this point. But importantly, when these are submitted to the queue, they're done sequentially with dependent queuing. Now, this is the sequence of scripts that I'm going to run, so these history template batch scripts, A through E. And what I want to do is I want to load configuration files that define how they're going to run on a cluster. So the configuration files are stored for each study, and basically there's the config A, B, C, D, and E. Now if I load these are objects, and they can appear in a property grid. And what this holds is information about the cluster. In specific, we're running on the shared hierarchy of academic research computing network, SharkNet, specifically the Hound cluster. The dependency path is on the cluster where I'm keeping my EEGLAB, and the software that I'm going to run these scripts in is Octave. So these basically generate M files that are then transferred over to the cluster and then just executed in time for each. Now, some of the queue properties, I'm going to run this job threaded with 3 CPUs per proc and 3 threads, using a total memory of 24 gigs for this job on specifically the Xeon processors. Now, we have other information here, and this basically holds all of the information about how this first script is going to run on the files that I select. The work path is basically the synced folder on the cluster where the data are located remotely and matched on my local drive. And then some information about how it's going to name this job on the cluster, and some initiation code. So these are text files that are executed in the terminal before the jobs actually begin. And then what we see is actually there's a configuration for each of the history files. In particular, the fourth, D, there is no software that this will run in. It's simply the AMIC 12 OMPI new binary that's going to run in the MPI queue with 4 CPUs on the Opterons. Now, once I'm happy with the way that these are configured, then what I can do is I can select some data files. So these are located on my local drive, and I can just choose them from this browser, and I've synced these up to a specific location defined in the configuration files on the remote cluster. It's here. So once I have my series of history files, and then the configuration files that determine how each of those is going to run, I can just choose a series of data files, and these procedures will run on all of these simultaneously. So I'll hit OK. It'll ask me for my credentials on the cluster. Now, in the terminal, in the MATLAB command line, it'll update what is being sent through a terminal, an SSH client, to the cluster. And we can see the actual job submissions and the job IDs that are being returned. And then at the end of E, it releases it, and the jobs are now running on the cluster. So if I open a terminal, and then I log in, and then ask for the jobs running, see a bunch of these jobs, and then ending with the submissions that I just put in. So here we can see that these are now the A jobs, preproc A, threaded across 3 CPUs, and then the B jobs, the C jobs, and then the MPI Amica jobs, and then the E jobs. And as these get into the queue, they will run in parallel, and then as they finish, the queue will just keep toggling through.